Hello, everyone. Please switch on your cameras, everyone. Right? One simple question. I'm starting with a very simple question. We have already done this, right? Question is double A, double B, double C, D, E, F. How many of this? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have to arrange these 9 letters in such a way no two no two A's or B's or C's are coming side by side. This is a simple question. We have already done this type of question, right? And I hope you all know this, right? So we have to start from this. Then gradually we have to go for purple commit. Very, very good question, right? So started with this. You all know little bit about probability, Kavyam, संजना, उत्कर्ष, तन्मय, आर्यन, सिर्फ तो बता दिया था मेरे को, राइट? यू हैव टू विहान, ऋषभ, you all know little bit about?
So not that much in detail.
But little bit, what is the probability and all, to, right?
Yes, sir.
The cases for cards and dices.
No,
हाँ सर सेम हियर इतना भी ज्यादा डिटेल
um, not required the cases in card. The requirement is the number of cases when we have to create. Very good, Rishabh. No two A's or no two B's or no two C's are together, right? Aryan, cameras. Sanjana, Kavyam, your cameras, please. May I start?
सॉरी सर आई वेंट टू द बाथरूम वन
This is a very good arrangement and 100%. I'm pretty much sure that this time again you are getting one question from this. So you have to be very good with the concepts. May I start? Receive. How you are going to solve it?
So inclusion exclusion principle.
Very good. So answer, just you have to write down the answer.
So
Sir,
Mm-hmm.
sir, I have taken up an approach same to this inclusive exclusive principle. Sir, what if we just took, for example, two letters consecutive and are
Mm.
also same?
Mm-hmm.
So then we can variate upon that, choosing A, B, C out of them and then placing them and then doing that. Then we
Right.
can make another case for four letters as an A, B, B, A, C, C like that. We can variate those. And lastly, all three are together and then we can take a final subtraction for that.
First case, what we are taking, if no restriction is there. So I'm writing this as factorial 9 by factorial 2, factorial 2, factorial 2. Is this okay? Is this okay?
yes, sir.
But the symmetricity is there. So I can say exactly two AA are together. I'm writing 3C1 or BB are together or CC are together, right? So 3C1, right? Exactly one must be together. So if let's suppose I'm saying AA are together to 1, 2, 3, 4, 5, 6, 7, 8, factorial 8 by factorial 2, or exactly one pair must be together. But this include the, like we have counted twice few of the cases. What are the cases? When we are saying exactly two are together. So if A and BB or any two of this, so I'm selecting this by 3C2, 1, 2, 3, 4, 5, 6, 7. Factorial 7 by factorial 2 minus factorial 6. This is the answer. For more concept clarity, I can say, let this is a universal set, right? In this universal set, I'm drawing three diagram for right. So this is the universal. Universal means we are taking all the cases, right? A, B, C, double A, double B, double C, D, E, F, F. And this is for double A. This is for double B. This is for double C. So what we required, right? What are the portion we require? So we require the portion, this one. No two A's, no two B's, no two C's are together. So we require this one, this portion. I hope everyone is getting this, right? So this portion is required, right? So how to get this portion? So first I'm writing the universal set. This is 9 factorial by 2, 2, 2. This is the universal, so complete set. Now, what I'm saying, maybe double A's are together, right? So double A's are together, so I have to subtract this one. Double A's are together, or double B's are together, or double C's are together. This is for double A, right? So this is for double A. Now, I'm saying double B. For double B, again, I have to subtract this. But you can see this threaded portion coming in the way, right? Two portion of this is coming, right? So this portion, right, the in between portion, we are saying 2 times, right? And again, I'm going for double C. So this portion, I'm going for 2 times. So you can see this, right? Very easily, we can identify this. A few of the portion, like this is the portion, or this is the portion, or this is the portion. We have taken 2 times, right? So I have subtracted, I want to subtract 1 time, but going for 2 times. So again, I have to add this thing. So I'm adding this thing, right? But in addition and subtraction, we have lost this one completely. But 1 time we have to write, right? So we have to just go for that. Right. So this is inclusion, exclusion, but my question was not this. This is for the revision of everyone. I hope everyone is getting it. Anyone want to ask anything on this?
Sir, in the last, how did we get the -6 factorial?
Minus 6 factorial means if all the double A's, all the double B's, all the double C's are together. So this is one, this is one, this is one. So this is coming 1, 2, 3, 4, 5, 6. So 6 different letters we can arrange in factorial 6 ways.
So
Okay.
basically, what
why
we are
did
trying to
do 3C
uh,
to factorial?
Hmm?
So why did we do plus 3C2 into 7 factorial?
This one, 7, 3C2. See, what is happening here? I want to subtract C from the formula, right? The formula of an A union B union C. So first I'm writing NA plus NB plus NC. So in this formula, I'm writing this portion. I guess you can see this portion twice, and again, this portion twice, and again, this portion twice, right? So I have to subtract those portions. So N A intersection B minus N B intersection C minus N C intersection A means we have subtracted all the portions. So we are not taking any number of time, but we required exactly one time. So again, right? So this portion I have to add one more time. So we are saying N A intersection B intersection C. So if you'll see this now, this plus sign, so this is coming as summation NA minus summation NA intersection B plus NA intersection B intersection C. So sum taken one at a time minus sum taken two at a time plus sum taken three at a time. This I'm subtracting from universal set. Right? If this I'm subtracting from universal set, so I'm getting right this portion. Right, Tanmay? Okay, beta?
Yes.
Right?
Sir, so what I was trying to say in the 6 factorial, what you tried to do is take A as one object, B as one object, C as one object, and then D, F separately as one object that's add up to 6, right?
Exactly.
Okay, sir.
But
Okay.
my question is, if I'm giving you the question in this way, A, B, C, you have to arrange these 5 or 7 in such a way, no two A's or B's or C's are coming together. Please try.
Sir, is my answer correct?
No. Calculate what is the answer coming up. Just calculate the complete answer.
Sir, I've kept in factorial. Should I do the
Remove
whole
that
answer?
factorial, calculate the answer.
Yes, sir.
Done.
So 1 minute.
Think I did something is wrong, Aryan. Think on this.
Okay, sir.
Calculate, reserve, calculate the complete thing. How much you are getting, just go through that. Just you have to calculate exactly how you are going to take the things. No, 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 no reserve. Are including more of the cases. More cases you have to reduce time. Kavyam, Tushar. May I start?
Sir, one
So
more minute.
1 minute calculating factorials.
Okay, good.
Sir, I've done.
No, Aryan. So if you think na ki in competitive examination you'll get the direct question of inclusion, exclusion or something. So this is not going to happen, right? Something you have to do, right? Sanjana, no, you have to reduce down more numbers on that, I guess. Tushar. Not bad, not bad. Tanmay, anything? Rishabh, Utkarsh. Not bad, Sanjana. Good try. Rishabh is well, it's too high. 300, so I guess total number of cases are not there. Huh? Yeah, yeah.
Sir, it should be less than 300 only. I according to both of my answers, it should be.
Rishabh, how you are getting this number? Sanjana, how you are getting this number?
यार मैंने एक और केस ढूंढा जो माइनस करना था, तय किया था.
Okay,
So जब डिस्कशन स्टार्ट करेंगे तो इंक्लूड.
okay. Just a minute. No, gives 2 minute time. I guess everyone will be comfortable after that. Huh? Let's start.
The last minute calculation में जा रहा है.
Okay, no problem, beta. Take your time. The total arrangement is, I guess, 7 factorial by 322.
Yes, sir.
210.
210.
Sir, but that is without any conditions, right? It
Without
would be much lesser than that.
100%. 100%. This include all the restrictions, right? So let's start. Done, Vihan? Utkarsh? Utkarsh?
सर कर रहा हूँ अभी भी.
Okay. चलो लास्ट 1 मिनट में कोशिश करते फिर विल डिस्कस ना. Sanjana, why you are writing this number, beta? 66. How you are writing this? You can say na, I'm not required to write it down. 7 factorial. 7 factorial 222. Why 7 factorial upon factorial 2? In the first case, there are 3 A's na. So 3 identical things are there. You have to divide by factorial 3 na. $98 काव्यम पहुंच गया घर क्या? घर पहुंच गया क्या?
Yes.
चलो ऑफिस से स्टार्ट कर लेते बेटा. Why 98? How you are getting 98?
Total number of cases is 5040 divided by 3 factorial, 2 factorial, 2 factorial. Then will subtract each of the individual cases. So keeping all A's together, the number of cases will be 5 factorial by 2 factorial, 2 factorial. And keeping either B or C together, the total number of cases will be 6 factorial by 3 factorial, 2 factorial.
Very good.
And then we'll add A intersection B and B intersection.
But try to understand, one more cases we have to subtract and we are not able to subtract those cases. When we are saying exactly two A's are together. And that case is not required.
Yes, yes.
Nah? So that we have to subtract from those. Nah? Yes. Rishabh, your turn now.
सर मेरा भी स्टार्टिंग ऑलमोस्ट ऐसा ही था कि पहले 7 फैक्टोरियल बाय 3 फैक्टोरियल 2 फैक्टोरियल 2 फैक्टोरियल यूनिवर्सल सेट। उसके बाद मैंने फिर दो केस बनाए कि पहले मैंने जब दो चूज किए, जो एक चूज किया वो रिपीट कर रहा है, तो या तो ए रिपीट कर रहा है या फिर बी या सी में से कोई रिपीट कर रहा है। तो 2 इंटू 6 फैक्टोरियल बाय 3 फैक्टोरियल 2 फैक्टोरियल और फिर 5 फैक्टोरियल बाय 2 फैक्टोरियल 2 फैक्टोरियल। अब कोई भी दो का हमें चाहिए था कि दोनों साथ में रिपीट कर रहे हैं, तो मैंने एक बार ए और कोई बी सी में से लिया या फिर बी और सी दोनों ही ले लिया, ये किया। उसके बाद एक केस ऐड किया जब तीनों ही रिपीट हो रहे थे।
Okay. 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 Not bad.
एंड सर मैंने फिर आपने बोला कि आंसर गलत आ रहा है, तो मैं एक और केस ऐसा किया कि नो टू एज है, तो मैंने 3 एज को साथ में लेने का उसका अलग से एक और केस बना। तो मेरे को तो फीलिंग गलत आ रहा है कि वो गलत है, बट आपने बोला ओवर काउंटिंग होगी प्लीज।
Okay. Anyone else want to explain or want to say something on this? Or should I start? See, this. Yes.
सर तो मैं क्या किया था कि फर्स्ट तो सबका जो कॉमन है 7 फैक्टोरियल बाई 3 फैक्टोरियल 2 फैक्टोरियल 2 फैक्टोरियल। फिर उसके बाद मैंने क्या किया कि फर्स्ट मैंने लिया दो केसेस। एक केस की अगर हम लोग का आइदर दो इक्वल हो जाएंगे, मतलब कि अगर दो लेटर्स एडजेसेंट हो सकते हैं जो कि सारे लेटर्स के साथ हो सकते हैं, तो मैंने क्या
अभी देखते हैं। This is the case ना, so this is coming as 210. So this is the case. See, what is the problem? Problem in this question is the symmetricity, right? This is not the symmetric case, right? Maybe if I'm giving you the question like A, B, B, C, 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 so maybe you'll be able to solve this in the like easiest format, right? But if these three are same, these two are not, like the numbers are not equal, so the symmetricity is not there. So every time we have to calculate or count the numbers, so that may be a big problem. So obviously you have to understand key. Next question will be this one, right? Now, see. So this is total number of cases, right? When we are saying key, right, we have no restrictions, right? And second case, I have to subtract all those cases when exactly one pair must not be coming side by side, right? Exactly one pair is like, I have to subtract. So for those cases, I have to subtract all those cases when they are coming side by side, right? So case one, two B's are together, right? So if two B's are together, I'm not bothering about A's and C's. So what I'm saying, this is 1, 2, 3, 4, 5, 6. Factorial 6 by factorial 3, factorial 2. Same with two C's, factorial 6 by factorial 3, factorial 2's, right? But what about A's? How many cases of A's will be there, right? If I'm saying no, exactly two A's are not together. I'm not saying exactly three A's are. I'm saying no two A's are, right? Exactly two A's are coming side by side. Three A's are coming side by side, as well as two A's are coming side by side. That both the cases we have to subtract. I hope all are getting this. Just what I'm saying now, this is given B, B, C, C. In this case, I have to subtract two cases. First case, when I'm saying A, all three A's are coming together, and I have to subtract all those cases, double A and A, but not both are coming side by side. Right, the first case 1, 2, 3, 4, 5. So this will be factorial 5 by factorial 2, factorial 2. And for this, right, I'm saying we have to arrange all those cases 1, 2, 3, 4. So factorial 4 by factorial 2, factorial 2. And number of gaps are in this case 1, 2, 3, 4, 5. So 5C2 into factorial. Is this okay? So this is the case when we are saying we have not taken these cases also, right? So I have to subtract all those cases, right? So we have to subtract these two. So factorial 5 by factorial 2 minus 5C2 into 2 factorial into 4 factorial 2 factorial 2 factorial. Right. Is this okay?
Sir, can you just explain once from the start?
The starting I have done, I have started with exactly no restrictions are there. So we have started with factorial 7 by factorial 3, factorial 2, factorial 2, right? Then we said exactly from the last question we are coming, we have to subtract all those cases when two articles are coming side by side, right? Two articles are coming
Sideways.
right? Two articles are coming side by side, right? So two articles are coming, so I'm okay with B's and C's, right? I know exactly two A's are two B's are coming to it, two C's are coming to it. So exactly one pair of two B's are taken as a packet of one and then counting the numbers. But I have a problem with A's. Right, I have the problem with is, so we have to subtract two cases, right? Exactly three are together and exactly two are together. Exactly three are together is a different case than exactly two are together are the different cases. Is this okay?
Sir, but the bees can take any position if we consider them as 1, 2, 3, 4, 5, 6. Sorry, 7 slots, then the two bees can occupy any 2 slots. So then that isn't included in 6 factorial divided by 3 factorial divided by 2 factorial.
Sorry, I'm not getting this.
Sir, if we take all the letters to be slots, so there are 7 positions. Now, for keeping the bees together, then the rest of the permutation will be fine. There are 5 letters left. So how come 6 factorial is coming?
If I'm writing two B's are together, so I'm saying this is a packet.
Yes, sir.
Right, and now this is one. This is I'm counting as one, right? And A and C, right? So C, how many like alphabets like packets are there? I can say 1, 2, 3, 4, 5, 6. In these 6, these
Okay,
are
sir.
together and these two are together. So I'm saying that understand now?
Okay,
That
sir.
I'm putting, right? So, right. So I hope everyone is getting this now. But and now what you have to do, right? So this about exactly one pair must be together, right? And but we are not able to handle this because in those cases this is coming as right. So I have to go for the plus with double B's are together, double C's are together. First case. Second, double B's are together, double A or double B's are together, triple A's are together. This is two cases of this because C case RB you have to do the same thing. And again, minus with triple A, double B, double C. Or we have to minus double A, double B, double C, and A. I hope everyone is understanding this. Are you getting this? So this is not the exact similar case or the simple case of inclusion exclusion. The somewhere we have to use, right, the form or the formulas of this where we have to count the things.
Sir, can you just explain how you got a 5C2 into 2 factorial than the last one?
Yes.
Yes.
See, what I'm doing, I'm saying ki one of the case I have to take when two A's must be together and one A must be separated, and one A is not coming right side by side to two A's. Are you getting this? I have to separate two A's to one A's also, and rest of this is BBCC. So I'm writing this as BBCC, right? So how many gaps we have? 1, 2, 3, 4, 5. In 5 gaps, I have selected 2 gaps. Why? Because I have to put in one gap A and the second gap double A. So 5C2, I'm selecting 2 gap, and we can arrange these A and double A because both are different. A's and double A's in two different like position. So this I can arrange in factorial 2 ways. But these B, B, C, C can be arranged in different ways, right? So 4 letters are there in which 2 are same and 2 are same. So this will be factorial 2 with factorial 4. Is this okay?
Sir, but two A's cannot be together, so why are we taking both the A's in one packet?
Arey, what I'm doing now, I'm applying this formula beta again. First case is the universal set. Then I have to take exactly 2 R coming together. Then I have to subtract all these cases when exactly 2 are coming together. Then I have to add all the cases when exactly 3 are together. This was the inclusion exclusion. Na?
Oh,
So
okay.
using again that formula, but like cases are not symmetric. So that's the reason one by one I'm coming into this. Now you can calculate this, please.
Sir, so just to summarize, basically first we are taking the total, then we are going to take the cases where BB is together, take the cases where CC is together, then we also have to subtract the cases where two A's are together or three A's are together.
Very good. Plus, then plus
Plus then BB and CC together, BB and AA or BB and AAA, and CC, AA or CC and AAA.
very good.
And then finally all together.
All together, but in that case also you have to take B, C, C, A, and A. But A is separated from double A. Right?
Yes, sir.
So this is one of the way we can go through this. But
Excuse me, sir.
yes, beta.
So what if they, instead of arranging them, they gave us to select the alphabets and then arrange them, like selecting 4 at a time?
Selecting 4 at a time. Very good, very good, very good. See, so this is called Wilson theorem. One of the way to solve this is the Wilson theorem, and other way is the same as a counting one. So I will go with both the methods. And good question. Say, what is the question is A, B, B, C, C, and how many? 4 is okay now? We have to select 4.
Yes, sir.
We have to select 4 and arrange them in how many ways we can do that, right? So
Yes,
first method is, acha, I have to come again with this question na. I'll just will go with ki only by choosing the places how we can do that, right? But first see this one. If we are saying ki A, B, and C are given, and we have to select 4 alphabets out of these 7 in such a way, right? Well, only this is given. We have to select the ways. So case first, all 3 same one different. Case first, 3 same, 1 different. Is this okay? Case second, 2 same, 2 different. Case third, 2 same, 2 same, 2 same. Case 4, all different. Possibly नहीं है, but फिर भी मैंने लिख दिया. Right? So, 3 same must be from A's only, and 2 different from B, either B or C. So this will be 1C1 into 2C1, and we can
It is
arrange
2.
this by factorial 4 by factorial 3. Is this okay?
So can you repeat this one?
1C1, I'm writing 1C1 for all 3 A's. Right, only one option we have, all 3 A's are together, right? All 3 A's are same. So I'm saying 1C1, I'm selecting 3 A's from that, because no one letter is having 3 same cases, right? And now one different can be from either B or from C. So I'm saying that's 2C1, it's coming from either B or C. And we can arrange this by, obviously 3 are same, 1 is different. We can arrange these by factorial 4 by factorial 3. Right? Case 2. When 2 same, 2 different. So 2 same may be from any of the 2 from 3. So I'm selecting 2 same by 3C2 ways. Right? So let this may be A or B or C, and 2 different is coming from again 2C2. Try to understand this thing, right? I'm saying 3C2 means any of double A, double B, double C are coming in this case. So let's suppose double A's are coming in this case from 3C2. Now we have BB and CC. Right, so B's and C's are there. So I'm saying 2 different will come from 2C2 ways, right? And this can be arranged by factorial 4 by factorial 2. Next case, 2 same, 100%, 3C2. From 3C2, I'm selecting either 2A, 2B, 2A, 2C, or 2B, 2C, right? So 3 ways. And this could be in this case, and this is the 0 case, right? So this is total number of cases. Is this okay? But Wilson has given a very good formula for this. Right, so क्या बोलते हो वो भी बता दूं?
So is it generalization?
Generalization of this. Done, everyone?
Yes, sir.
Yes, sir.
See, now,
So, so the question was to select 4 and arrange them. Sir,
select 4 and arrange. If we have not to arrange, so we have not to multiply with this. Only selection process will be here only. Select and arrange, then I have to multiply with the numbers, right? So the formula he has given is for this question, factorial right? In this, we required coefficient of alpha to the power 4. That's it.
Sir,
Sir, what is alpha here?
Hmm?
Sir, what is alpha here?
Alpha is the representation of A's and B's and C. This first one contain for triple A's. Second contain for double B and double C. See, but this is very simple. Now, this is very simple. First, relax. Now, this is one of the simplest thing what he has done. Right? What he is saying, okay, you have to select A's. So A's, no A's is one way. 1A is alpha. by 1, right? If you are selecting 1, 2 A's you are selecting to, and you have to arrange to alpha square by factorial 2. Factorial 2 is for the arrangement. And if you are selecting 3, so he's saying कि alpha cube represent the 3 A's, and factorial 3 saying कि when this has to arrange, obviously the repetition is there, so you have to divide this factorial, right? Again, for B, he is saying the same thing. And for C, he is saying the same thing. Right. So that's the reason I have multiplied both this. So you are getting the same power 2, because B, number of B's and number of C's are same. Right.
So why 4 factorial?
Why factorial 4? Factorial 4 is for the arrangement of 4 alphabets, because you have to select alpha to the power 4 and arrange them. If you required 5, so you have to multiply by factorial 5, and you'll get the like each and every these cases I am able to write down from this formula. And the best part of this is, first note down. This is Wilson theorem. First note
Sir,
down.
so alpha represents what exactly?
Alpha represents that the identity, like how many A's or B's or C's you are selecting, is represented by alpha.
Sir,
Okay, sir. So
Yes.
so
sir,
if
sir,
Yeah.
4 factorial are the number of cases, no?
Pardon, once again, please.
The 4 factorial
Is for the 4 alphabet we are selecting, and we have to arrange those 4. For that, we have written factorial 4.
So alpha is different in each case?
Yes. Alpha is the identity that's contained by A, right? Alpha says कि alpha to the power 0 means we are not taking any A's. Alpha to the power 1 means we are taking 1 A. Alpha square represents we are taking 2 A's. Alpha cube represents we are taking 3 A's.
Sir, so could we say that basically alpha represents it like that, such that suppose we were taking 5, so then it would become 5 factorial, and if there were actually 3 objects that were same, and then
We can form a question now. Just we can form a question now. No worry. See, I
So
understand.
can you give an example to apply this?
Like I'm saying, like this is A 4 times, B 3 times, C 3 times, D 2 times. Now 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. Now I have to select how many? 5? 5 from this, right? And arrange them. In how many ways we can arrange? Take your time, everyone. Patyus, Tushar.
Yes, sir. Sir,
Yes, sir.
सर अल्फा टू द पावर 4 का क्यों हमने पावर कोएफिशिएंट दिया था एक बार आप
Alpha to the power 4 is, for alpha to the power 4, we are saying na, right? Because it was given कि you have to select 4, right? You have to select 4. That's the reason we have written alpha to the power
So how
5.
can I write it in the form of Wilson's formula?
That's the reason I have given this question. Na? Just you
Okay,
have
sir.
to that
Sir, 1 minute.
Just I'm going to explain better. Just a minute. Just a minute. The calculation part is more interesting, right? So writing down the answer is always the simplest part, right? The calculation, how to calculate this will be more interesting, right? So let's, if I'm saying, may I start?
So 2 minutes.
Okay, okay. Done, Kasib? Reserve? Tanmay?
सर इफ पॉसिबल आप थोड़ा सा ऊपर ले सकते हो, मैं सारे का एक बार स्क्रीनशॉट लेना चाहता था.
I'll explain this again, Reserve.
यस सर, बट वो पहले का लिख नहीं पाया था.
Sir, I'll send the
Very good.
Answer once the previous questions also. Yes sir, thank you sir.
Okay. See, very good, Aryan. Very good, Peter. Alpha to the power 5, we required coefficient of alpha to the power 5 into factorial 5 from 1 plus alpha square by factorial 2, alpha cube by factorial 3, alpha to the power 4 by factorial 4 into 1 plus alpha by factorial 1, alpha square by factorial 2, alpha cube by factorial 3, the whole square, and into the last one, 1 plus alpha square by factorial 2. Hope everyone is getting this. And from this, we required coefficient of alpha to the power 5. But Utkarsh, understand this.
Yes, sir.
But how to count this, right? How to solve this? That's the biggest challenge, right? So if you know this, now e to the power x. Anyone know the formula of this? The expansion 1 plus x by factorial 1 plus x square by factorial 2
The
plus.
Taylor series.
Yes, Peter. Taylor series or the Maclaurin series to infinity. This is e to the power x, right? So if you'll see this, right? The first one is nothing but e to the power x minus alpha to the power 5 by factorial 5 and so on. But we required only alpha, up to alpha to the power 5. Second one is e to the power alpha to the power 4 by factorial 4 minus alpha to the power 5 by factorial 5, the whole square. And third one, I'm not writing anything. Now I can multiply both the terms. So it will be easier to find the value, right? This is.
Sir,
Right.
could you explain again why are we subtracting e to the power x?
Not subtracting, but we are rewriting this. We are rewriting this so we can calculate this in easiest form.
Sir, so
If we'll multiply both the term, so directly we'll get the coefficient. Not required to write down each and everything.
sir, so I don't understand how e to the power x minus.
Just I'm multiplying these two only now for just showing you how you can calculate. For that, I'm just multiplying these two terms. So if I'll just go for this, right? The expansion e to the power 2x alpha to the power 8 by factorial 8 plus alpha to the power 10 by factorial 5 the whole square, right? Minus e to the power x into alpha to the power 4 minus 2 into e to the power x into alpha to the power 5 by factorial 5 and so on, right? But we know that, right? What we required coefficient of alpha to the power 5. So if I'll multiply both the terms, so from where we'll get alpha to the power 5, right? If e to the power x multiply with this to e to the power 3x, e to the power x multiply with e to the power 3x. So in this expansion, what is coefficient of alpha to the power 5 or x to the power 5? This is 3 to the power 5 by factorial 5. Is this okay? Is this okay? Because we have already seen that the expansion e to the power x is 1 plus x square by factorial 2 plus x cube by factorial 3, x to the power 4 by factorial 4, and so on. But in place of x, there is 3x. So what is x to the power 5, coefficient of x to the power 5? This is 3 to the power 5 by factorial 5. Are you getting this?
So
Yeah.
can you scroll up?
Yes, beta. Rehan,
Sir, not exactly clear.
which one, beta? Which step? Which step? This multiplication?
सर उसके पहले से मुझे समझ नहीं आ रहा है कि why are we subtracting that alpha, what is alpha, वो सब मतलब
अच्छा
clear नहीं है.
no worry, no worry. See, alpha, we are just give me 2-3 minutes. Huh? Just everyone note it down. See, what I'm saying, like if we have to, is this okay, everyone? I'll proceed.
Yes,
Yes.
sir.
See, what I'm saying, like in mathematics, we have lot many tools to count the numbers, right? If I'm saying in a bag, right, there are 2 blue balls, 5 green balls. In the second bag, we have 3 blue balls and 2 green balls, right? Okay. What I required, so I need 4 ball from the bag, right? 4 ball from the bag, right? The green ball or the red ball, right? So how we can find from one bag only, right? How I can found 4 balls from this bag, right? 4 green, 0 blue, right? 3 green, 1 blue, right? 2 green, 2 blue, right? So you can count one way, one way, one way. Is this okay? Right? To total number of ball, what we required is 4. I'm saying, no, I'm not doing like this, right? I'm saying, I'm writing this blue balls as alpha to the power 0, alpha to the power 1, alpha to the power 2. Alpha represents how many balls we are taking, that is blue. Is this okay?
So should alpha equal to 2?
Alpha to the power 0 represents no blue balls we are taking. Alpha to the power 1, we are saying exactly 1 blue balls we are taking. Alpha to the power 2 means 2 blue balls we are taking. Alpha is the base of that. Alpha is the base of that, right? And the greens are, is this okay? Right? Greens, I'm saying if green, no green balls, so beta to the power 0. If I'm representing green as the base of beta. Beta to the power 0, beta to the power 1, beta to the power 2, beta to the power 3, beta to the power 4, beta to the power 5. Is this okay? What I'm saying ki if I'll multiply both this and I'm getting the complete power of 4, alpha or beta, the power of 4 will work, right? So what I'm proposing or what I'm saying in this question, a blue balls I'm representing or balls I'm representing of one color like blue balls is alpha to the power 0, alpha to the power 1, alpha to the power 2. Is this okay now? And again, the second identity balls are again alpha to the power 0, alpha to the power 1, alpha to the power 2, alpha to the power 3, alpha to the power 4, alpha to the power 5. Is this okay? Now,
So alpha does not matter and only the coefficient matters.
yes. So now what I required alpha to the power 4 from both this. So our requirement is the alpha to the power 4, right? Alpha to the power 4 coming from multiplication of both this means if this is 0, this is 4, this is 1, this is 3, this is 2, this is 2, right? So how many cases are there? 3. If I'm saying no, I'm smart enough to solve this by mathematical formula, right? So what is the mathematical formula for this? So if I'm able to write down, or if I know this, right, 1 minus alpha cube upon 1 minus alpha, the GP formula, this is 1 minus alpha to the power 6 upon 1 minus alpha is a formula. Or ultimately, I'm getting 1 minus alpha cube, 1 minus alpha to the power 6, 1 minus alpha to the power minus 2. If I know the formula for this or formula for this, so I'm able to write down alpha to the power 4, the coefficient of alpha to the power 4. What are the numbers coming? That will be the answer, right? So ये जो complications दिख रहे हैं ना, right? ये complications जो हैं, ये simple हो जाते हैं when we have to solve a very, like the questions are very complicated.
Okay, sir.
Right?
समझ गया.
So this we have to build for questions, right? That's the reason we have built ki, okay, we are concentrating on the identity only, the numbers only. We are not concentrating ki how much it is coming, right? That's the reason I'm taking alpha for both, right? Now, but in this case, like this case, we have to select as well as arrange. We have to select as well as arrange. That's the reason if it's coming as alpha square, I have to divide this by factorial 2. If it is coming alpha to the power 4, I have to divide this by factorial 4. I hope everyone is getting this, right? So it depends on like how we are going to do. Now,
So the series is infinite, but we only consider a part of it.
part of this, right? Because we require the smaller powers, right? We are not concentrating for alpha to the power 10 or something, right? Because maximum number of balls or maximum number of alpha betas 4, right? From each maximum, it's going to 4. Okay. Now, so this was the one, right? And what I'm saying, this is your homework. Write down everyone. A, B, and C. We have to arrange these 9 letters in such a way no two are consecutive. No two same alphabets are consecutive. Right? Right? Okay. So one question I'm doing for the sake of key, like you have to know the probability part, right? So if I'm saying I have to throw a dice and probability of getting 6 on the dice is 1 by 6. Is this okay? Probability of getting 6 on the dice is 1 by 6. All you know this? All you know this? Everyone?
Yes.
Yes, sir.
What is the meaning of this? Everyone has to interpret this key exactly what he or she is understanding, right? So if I'm tossing or casting or throwing a dice and it's coming as 6, coming up 6, the probability. So what is the probability of coming up 6 is written by 1/6. What is the meaning of this? Right? Oh, who is going to explain?
Sir, may I say?
Yes, please.
Sir, so basically it is saying that there is a one out because there are a total of 6 cases that can happen. Either the first case can be that the dice drops 1, 2, 3, 4, 5, 6, and others, and then after that we can like there is only one case in which we can get 6. So that's why there are only one case is divided by the total cases. So there is a one chance in every 6 dices, every 6 attempts that we might get 6. Or if you are unlucky, we might not.
Okay, Sanjana.
Sir, I'm Arif.
Sanjana.
So,
Go ahead, beta.
sir, I had the same explanation. Like,
What?
the one we know that probability is equal to the number of events upon, like the events of the particular upon the sum of the total events. So getting a 1, we have only one possibility, so that upon 1/6, which is the total events, so that's how we get.
Well, but my concern is that is a formula only. What you are understanding that the formula or the understanding is something different.
So for example, if we have a pie and then we divide it into 6 parts and then we number the different parts as 1 to 6, and then we will roll the dice. If we get a 6, then we'll take out the pie that has the number 6 in it. So the pie is divided into 6 parts. So basically, at a time, there's only a chance of that we get one pie of 6.
Okay. Okay. And Vihan, Rishabh, Patyus, why your camera is off?
So probability of 1/6 मतलब 6 हमारे पास ऑप्शन है जो हो सकते हैं, उनमें से हमें एक ऐसा ऑप्शन चाहिए जिसमें 6 है, तो हम लोग ने वो फर्स्ट एक ऑप्शन चूज किया, इसलिए 1/6.
Kavyam,
वही out of 6 total outcomes if एक ही favorable है हमारे, तो probability from
okay. Utkarsh,
सर एक ही फेवरेबल कंडीशन है आउट ऑफ द 6 पॉसिबल वंस.
घुमा फिरा के everyone is saying the same thing.
सर लेकिन अगर हम लोग अनलकी है तो 6 से भी ज्यादा टर्न्स 6 से भी ज्यादा अटेम्प्ट्स लगेंगे.
What is the meaning of unlucky है? What is the meaning of this RM?
सर आई मीन कि अगर हम लोग का नॉर्मल प्रोबेबिलिटी है कि हम लोग को 1/6 मिलेगा, सो सपोज वी आर अनलकी कि बहुत ज्यादा चांसेस के बाद ही मिलेगा.
Why you are saying we are unlucky, then we will get the
Sir, because it's just a probability. It's not it's not a confirmation that we get a 6 in every one.
Your understanding is means your understanding is out of 6 throw, the chances are will get 6/1/6 chance.
Yes. If
your understanding, okay.
Sir,
Mm-hmm.
sir, building on what Utkarsh said, I also think that you can't, just because the probability is 1/6, that does not guarantee in 6 throws you will get the same thing. You can throw it a million times and still you can get something that's not 6 based on random chance. So only if you throw it, for example, 60,000 times, then you can say with somewhat assurance that around 10,000 of the times you will get 6, but you cannot confirm that on a small scale. Then only random chance will operate.
Who said
that's
this?
what I was trying to say.
So who said this? I'm understanding what you are saying, but who is saying this? If you'll throw 6,000 time or 60,000 times or 6 billion times, then 1,000 times or 10,000 times, you'll get 6. Or if I'm throwing 6 times, right? So like one time I'll get 6, right?
It's the most likely case, but it's not
ना,
important.
nothing. मतलब आस पास भी ये नहीं है understanding के लिए. That's the reason I have started from that. The probability means you have inspect a dice. I don't have dice, but I guess I have something. Right? Okay. Right. I don't have dice, but obviously 6 faces are there. Right. So if I'm throwing, I'll get white or green or something. Right. So what is the meaning of this? I'm just giving you the question ki if I'm throwing this Rubik cubes, what is the probability that I'll get white? So the meaning of this is if I have inspect this carefully, so I have seen that one side is white and no other sides is white. And they have 6 faces, right? And all are equiprobable. That's it. Probability is not like if I'm throwing something that many times, so that much time that will appears. Wrong concept. Only the concept is physically you have inspect this and you know that one side you are getting 6 and no other side is 6 and each and every surface is equally probable. Equally probable means you are throwing, then that the chances of getting a 6 is as good as chances of 1, 2, 3, 4, 5. Right? So probability is right. No chance, nothing. It's a mathematical form and method. So we have to go with the mathematical formula. Mathematical formula is required number of option upon total number of option. That's it. Right? If I'm giving you, I'm tossing 5 points, right? Find probability that will get exactly 3 heads. Exactly 3 heads. Very good. Abhyam. Very good, Utkarsh. Very good, Kasif. Very good, Sanjana. But the interesting part is all the answers are different. Very good, Vihan. Not bad. Abhyam, Aryan, good. See, the exactly 3 heads means what we required. We required exactly 3 heads means head, 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 and 2 tails, right? Out of 5. So what I'm saying, this we can arrange by factorial 5 by factorial 2 factorial 3, right? And total number of cases will be For every places we have two options, so this is 2 to the power 5. So this is 5 into 4 into factorial 3 by 2 factorial into factorial 3 cancel out upon 32. So this coming as 5 by 16. Very good. I hope this is a simple one. उत्कर्ष क्या किया?
सर ये नहीं देखा था अरेंजमेंट्स का.
Arrangement we have to do na, not exactly head tail na. It can
Sir,
be head tail head. Yes.
sir, the real point in the problem was understanding that we have to consider coins to be different because we are tossing them individually fine.
No. The coins are maybe different or maybe same, but I'm tossing a coin one by one. Let's suppose.
Ah, sir.
So time is different.
Yes, sir. So if they're
Right.
one by one, then obviously.
See, Sanjana, see. You have head, tails. We have 1, 2, 3, 4, 5. 5 chances. For this, how many options we have? 2 options. For this, how many options we have? 2 options. For this, how many options we have? 2 options. For this, how many options? 2 options. For this, how many options? 2 options. So total number of options 2 into 2, 2. So this is 2 to the power 5. In these, right, in these 32 options, what we require 3 heads and 2 tails. That we can write by factorial 5 by factorial 3 factorial 2. In how many ways? So this was, I guess, 10 now. 5 by 16. Right? Is this okay?
So what if we now have the same coin and we are tossing it 5 times?
No problem. The time is different. You have tossed a coin once, right? Time lapses are there. Right? So next coin when you are tossing, so that time is not same. So obviously now the different case is there. Right? So time lapse in the probability is one of the like we have to take this as a different task. But I'm changing this question to, right? Not exactly. Now I'm saying at least 3 heads. Tossing 5 coins. Now at least 3 heads. And please, now relax. We have to not give the answer in the fastest way. Fastest finger nahi chalna apne ko, right? Like we have to go for the rightest path, right? So take your time, relax. Next lecture, I'll do the tetrahedron, right? I'll try to go with the polyhedron and tetrahedron, right? And we'll go with this probability also, right? Probability and tetrahedrons.
Sir, I've sent.
Why you are so hurry? Huh?
Sir, easy tha.
Very good. Very good. Very good. At least 3. Who'll explain this? Who'll explain this, please?
सर मैं बोलूं?
Yes, please.
सर एटलीस्ट 3 हेड्स में पहला केस आएगा जब 3 हेड्स 2 टेल्स 4 हेड्स 1 टेल या 5 हेड्स, या फिर हम ऐसे भी देख सकते हैं कि 5 कॉइन थे उसमें हाफ केसेस में उन्हें हाफ में भी डिवाइड कर सकते हैं कि जब 3 हेड्स लेंगे तो 2 टेल्स आएंगे।
हाँ at least 3 heads. Why you are saying exactly 3 heads? Maybe it comes with the 3 heads and like at least na to 4 heads and 5 heads also na.
हाँ सर, वो सब गिनेंगे ना, टोटल में ऐड करेंगे अलग अलग प्रोबेबिलिटीज.
Okay, so you have counted with exactly 3 heads, then exactly 4 heads, then exactly 5 heads.
Yes.
Okay. Yes. Same, everyone,
Yes, sir.
right?
Sir,
Hmm.
can we rather say that, sir, because we were all saying that we have to count them differently, the coins.
Hmm.
But sir, I think that rather the reason why our approach is working is because the outcomes themselves are different. So we have to permutate them differently.
Mm-hmm.
So that's why we are taking, if the outcomes are same, then it doesn't matter which coin it goes to. But if the outcomes are different, then it matters.
Yes.
Sir, I've sent you my answer.
Yes. Yes, very good, everyone. Right. So you are going with heads, tails, and hits, right? 3 heads, tails, tails. First case, what I'm saying, if I'm saying first case, in this case, right, what I'm writing, I'm not writing anything. I'm saying either maybe these two positions could be head or tail. Second is this tails, head, 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 and this. And third is this case. So this is the case 1 by 2 to the power 3.
So, but there's no case where T is in middle of H.
Right? So, right? This is the case when I'm saying 3 hits are there, at least 3 hits, right? So that's always simple thing, right? You have to count 3 hits and 2 tails, 4 hits and 1 tails, and 5 hits, right? So obviously you can count, right? But what if at least 3 hits and consecutive? Then you have to go with something like this. So there are 2 cases, right? If I'm saying exactly 3 hits, that's okay, right? But what if we have to go for at least 3, right? Okay. So the second question, what you have to try, we have to toss 10 coins, exactly 6 heads, 6 consecutive hits are required, right? So next lecture, I'll start from this only. Okay, everyone?
Okay, sir.
Thank
Right?
you.
Take care, everyone.
Thank you, sir. Bye, sir.
Thank you, sir.
Thank you,
Bye,
everyone.
sir. Thank you, sir.
Bye,